Hello, today we are going to do number of real roots in cubic polynomial equation. So let's see how we proceed. So ax cube plus bx square plus cx plus d equal to 0, that is a cubic polynomial when a is not equal to 0. Today we are going to find number of real roots, like for ax square plus bx plus c equal to 0. We know there is one term called d if d is greater than 0 to unequal roots, right? D equal to 0 to equal roots and d less than 0 no real roots, right? Means both the roots will be complex. We have not done this one, we will do it. So if we have some determining factor for real roots of quadratic, so what we have for cubic polynomial equation? So can we say if a cubic equation is given, how many real roots it will have? That's what we are going to deal in this topic. So before we move ahead, we will focus on graph of cubic polynomial. I hope everybody knows how graph of quadratic polynomial looks like this one or like this one, right? We have done this in details in quadratic equation in this topic in the beginning. This is when a is greater than 0, this is when a is less than 0. So this is graph of quadratic, right? So let's look at the graph of cubic. Graph of cubic equation will be like this one, or like this one, or like this one, or like this one. This is when a is greater than 0, this is when a is less than 0, this is when a is greater than 0, and this is when a is less than 0, right? So this is just I have tried to show you, this is how graph of cubic polynomial equation looks like. So we will be looking at the graph of cubic equation and then see when it will have one real root or two real root or three real roots. So let's look at this graph. Graph is like this one, right? These are called local maxima or local minima, right? This is local maxima and this is called local minima. If both the maxima and minima on the same side of x-axis, like if both are above, you will see one root. If you see this like this one and like this one, then you see how many? Then you see three root. Means if local maxima and minima are on the same side of x-axis, then you will have only one root. If maxima and minima are on opposite side of x-axis, then it will have three roots, right? And when it will have two roots, it will have two roots when you see like this one. So maxima or minima, this one, or it can be like this one. In this case, you will say it will have three roots, after them two will be equal, right? So if it is alpha, it will be beta and beta, two roots same, right? So you can say two root distinct root, or you can say three roots with two are same, right? So this means what we understood from this graph, we saw that if it has graph like this one, and then if both maxima and minima are on same side, then it will have one root. If maxima and minima are on the opposite side of x-axis, then it will have three roots, right? Now let us look at the other part. So you see the graph here, it is not like this one, right, where maximum minimum, it is kind of this one. So this is another type of cubic equation, we will deal on that, right? In this case, it will have only one real root all the situations. This means this is what? This is called increasing all the time. You see graph is always increasing, or it can be will have one root also if it is going like this one, coming down, this is decreasing. It is what? This first one we saw is increasing, then decreasing, then increasing, right? Such type of graph will have either one root or two root or three root, right? This is what? Position of x-axis. In this second situation, when it is increasing only, or decreasing only, right, then what happens, it will have only one root. So if I want to use this information, then we can actually conclude how many roots we will have in a cubic polynomial equation, right. So let's try to formulate this. So I first take which situation, I take this one, correct, and this one. This is maxima, this is minima. It is what? This is 3 root situation, correct. It could have been like this one also, like this one. So now how can we decide this? So for this is we need to take help of calculus, that is maxima minima. This means like what we did in quadratic, we applied algebra to find two roots will be distinct, equal or imaginary, right. Here we will be using calculus. Calculus has a theory of maxima minima. How do we do that? We find dy by dx, that is differentiation or derivative of the curve, and make it 0. It gives you critical point alpha and beta. Those will be this alpha beta, where it is minima or maxima, not the roots, right. So alpha beta will be the points where it is maxima minima, right. Then what we will be doing, one will be maxima, one will be minima. I will be finding f alpha and I will be finding f beta, right. So f alpha, if it is on the opposite side, one will be positive, see that above, one will be negative, or here you say one will be negative, other will be, this means product will be always less than 0. I will be using this one to see whether a cubic polynomial equation has 3 roots or not, right. So let's take one example. So I want to find whether this cubic equation has 3, 2 or 1 real roots, right. So what I will be doing, I will be considering this as y, okay, is equal to fx, you can say, okay. So I will be finding dy by dx. So dy by dx will be 3x square minus 12x plus 9, right. And then to find those maximum minimum point, I make it 0, right. So take 3 common, x square minus 4x plus 3 equal to 0, 3x minus 1 into x minus 3 equal to 0. So x is equal to 1 and 3, right. So 1 and 3 will be point of maxima or minima. I am not interested which one is maxima minima. If I take product of f1 into f3, f1 into f3, right. So f1 is what? Put 1 here, 1 minus 6, 9 minus 9 minus 5 into 3, 27, 27, this is minus 9, right. So it is what? It is greater than 0. This means what? Both are on the same side, correct. If both are on the same side, what will happen? It will be like this situation. Both are negative, so at 1 and 3 it is both negative, so it is kind of minus 5, then minus 9, like this one. See, this is graph of this one, and I can see it has only one real root. So I can say x cube minus 6 square plus 9x minus 9 equal to 0. It will have only one real root. So how we did that? We found dy by dx, find points of maxima and minima, and check whether these have both same sign or not. If it has same sign, then it will be on the same side and hence only one root. If it has opposite sign, then they are on the opposite side, it will have 3 roots. So let's take one more example. So now I take another question, find value of a 4, it has 3 real roots, right. This means what? And you will see it is same question almost. So x cube minus 6 square plus 9x plus a equal to 0 has 3 real roots. This means what? If I find point of maxima and minima, one will be above x axis and other will be below x axis, right. So for that I find dy by dx. dy by dx is 3x square minus 12x plus 9 equal to 0. Same thing, so it will be x minus 1 into x minus 3 equal to 0, x is equal to 1 and 3. Now f1 into f3 should be less than 0 since it has 3 real roots, right. So f1, if I put here, it is 1 plus 9 10 minus 6 4. So it is 4 plus a, f1 is 4 plus a. If you put 3 here, so it is 27, 27 and minus 54, 0, it is a less than 0. So this is the condition. Now how can I solve this? This is what? This is inequality. And how do we solve inequality? Using sign scheme. This means I need to find critical point. So make it 0, you get critical point minus 4. Make it 0, critical point 0. Plot number line minus 4 and 0. So I see highest power is a square, positive, positive, negative, positive. We are looking for less than 0, negative. This means a should be what? A should be element of minus 4 to 0. I think idea of this 3 roots and 1 root when it has graph like this one, maxima, minima, it is very clear, right? Now let's see when graph does not look like this one, but graph look like this one only, where there is no up and down, increasing, decreasing, increasing, only increasing, or it is kind of decreasing, right? Let's see that. I take y is equal to x cube plus 5x, okay. This one graph, if you plot, it will look like this one. So it is what? It is continuously increasing. So how we will see that? We will again differentiate it. Dy by dx is equal to what? 3x square plus 5. And you see, it is never, if you try to make it 0, it will not be 0. What it is? It is greater than 0. If dy by dx is greater than 0, it is called increasing. So if you see this graph, if it comes down or goes up, it will be only intersecting at one place, right? Means one root. So if it is always increasing, that is dy by dx greater than 0, it will have only one root, okay. If I take another example, y is equal to minus x cube minus 4x plus 3, then what you see? Find dy by dx. Dy by dx is minus 3x square minus 4. It will always be less than 0, right? If you plot its graph will look like this. So it is what? It is decreasing. So if it is goes up or down, it will have always one intersection point with x axis. So it will have only one root. Means what? If a cubic polynomial is always increasing or decreasing, it will have only one real root. So let me write it. So we can summarize the full theory into these 3 lines. First line is what? If cubic polynomial is always increasing or always decreasing, right? Means what? Means dy by dx is either always greater than 0, that is increasing, or dy by dx is always decreasing, right? It is not somewhere positive, somewhere negative. It should be if always positive, this means only one root. If it is always negative, it will have only one root. Second situation is what? If cubic polynomial is somewhere increasing, somewhere decreasing, means this one. We are talking about this situation. See, increasing, then decreasing, then increasing. In this situation, there are two things. First is, it will have 3 roots if maxima, minima are on the opposite side. Clear? It will have only one root if it is like this one. See, both maxima, minima are below x axis, or it will have this situation. This situation, see, maxima, minima both on the same side, it has only one root. Got it? That is second, this is this point. Third says it will have 2 roots when maxima or minima is 0. So it is this situation. Like this one. See, here minima is 0, right? So it will have one root here alpha and other root beta. So it will be repetitive root. So you can say 3 roots or you can say 2 roots. So you can say 2 distinct root or 3 roots where 2 are equal, or it can be this situation. Like this. See that? Again alpha, alpha, and this is beta. I think you got this, right? So next time when you are given a cubic polynomial, you can try this and find how many real roots it will have.